Okay, I've been asked for some help on how to graph with transformations. And here we have a problem that says use the transformations of the graph f of x equals x cubed to determine the graph of the transformed function r of x, which is equal to x minus 2 cubed plus 4. Okay, so we've got to take a look at a couple of different things here. So you're using these transformations, you need to consider what the basic graph is. So you can do that by making an xy table. The order of operations to move the selected points are always going to be the same. You're going to have horizontal shift first, then any stretching or shrinking, any reflections, this would be like a negative in the front, and then vertical shifts. So for this problem, the first thing you're going to focus on is the horizontal shifts. And this function has a shift that is x minus 2, and that means you're going to move 2 units to the right. So if we were working this out, we could come up with our new pattern of x and y. Once we've done that, you need to have a vertical shift, which is plus 4, and that means we're going to add 4 to each y value. Now, you can do that again by adding 4 to the different y values, and then you'll have your final set of points to graph. But in MyMathLab, we're going to do this a little bit differently. We're just going to tell it the shifts that we need. So for this example, we have a horizontal shift to the right, 2 units, that's a plus 2. And we have a vertical shift, which is 4 units up, and that's going to be a plus 4. So here's how that would work. So when you want to graph these, first of all, you need the graphing tool here. You need to pick up the correct function. So this one is a parabola tool, or x squared, and this one is the cube tool. So we'll pick that up and we'll just drop it into the graph. Here's where we need to make all of our changes. So we said that this one was going to horizontally shift 2 units to the right. So there we go. And it was going to shift up 4 units. Okay, so there it is, shifted up 4 units. And we can click that off. We're done with it now. Okay, now if you went back and look at the table of values, you should see, for example, the point 24, and it looks like the point 35, and those should match. Okay, we'll save this. I'm actually in a student view, so I can't check it, but that's how you do the problems.